Welcome back. Today we're going to look at a oxidation reduction reaction, which is called redox for short. And it's the third type of reaction that we'll look at the first part of this book. We've talked about neutralization reactions, and neutralization reactions is when two ions come together to form water. Then we had precipitation reactions where two ions came together and was insoluble and came out as a precipitate. This is the third type of reaction, and the third type of reaction is when an electron is transferred between two ions. So an electron is stolen or donated between two ions, and that's called a redox or an oxidation reduction reaction. So there's two processes going on at the same time. There's the process of reduction and the process of oxidation. It was called oxidation because the first redox reactions were in dealing with oxygen. When oxygen made iron rust or silver tarnish, that was an oxidation reduction reaction, and so it was named oxidation after that. So reduction means getting more negative, so reducing the charge. So you can think of it when an ox steals your electrons. Okay, when an ox steals your electrons, then that ox now has more negatives, and so the ox is reduced. So I have the skinny cow here. So if an ox steals your electron, then it becomes reduced. The ion that gains the electrons becomes more negative, and that more negative means reduced. The opposite of reduction is oxidation. So if gaining more electrons makes you more negative or it makes you reduced, then oxidation is where you're losing electrons and you become less negative. So you become more positive. Okay, so when an ox steals your electrons, then you become more positive because you don't have as many negatives. So you've been oxidized by an ox. I couldn't find a picture of an ox, so there's a cow. The ion that loses the electron is called oxidized. So here's a mnemonic that you can possibly help you. Oil rig. Oxidation is loss. Reduction is gain of electrons. So dealing with electrons. So here's a schematic that may help you a little bit. If ion A has an electron that's transferred to ion B, then A is oxidized because it's lost an electron. B is reduced because it's gaining an electron. Okay, so I think the easiest way for me to show you is with an example of a baseball catch and pitch and catch relationship within baseball. If the baseball is negative, if it's the electron, whoever has the electron is reduced. And as soon as he throws the electron, the other person catches the electron, then that person is reduced. So we don't just have the idea of whether you're reduced or oxidized, okay? Then there's also it's who's doing it to whom. So for instance, let's start with the pitcher. The pitcher has the baseball. The pitcher is reduced because he's more negative. He has a negative. As soon as he throws the ball, the pitcher becomes oxidized. He loses that negative. The catcher now catches the ball. He becomes reduced. Okay, so if you lose an electron, you become oxidized. If you catch an electron, then you become reduced. But the pitcher has done it to the catcher. The pitcher made the catcher become reduced. So the one who is oxidized is the reducing agent. The one who is reduced is the oxidizing agent. So the one who is getting the ball, getting the negative, is making the other guy oxidized. If you are losing the ball, you're making the other guy reduced. So I really hope this helps. Watch it as many times as you need to, and we'll have more later.